Hi guys, in this video we are going to discuss a question from active power, reactive power and apparent power. In our previous video we have already discussed about what's meant by those powers. If you haven't watched those, I have given the link in the description, so please watch them before doing this one, because first of all you need to know what are them, so after that only you can proceed with the question. So in this video we are going to discuss a question from that part. Also, if you are new to the Expert Tutor channel, please consider subscribing. Also, if you have any doubts regarding this question in the end of the video, please comment in below so I can also reply for them. Okay, without wasting our time, let's do the question. As you can see over here, they have given a voltage source with 15 voltage and 10 kilohertz, and there's a resistor with 1 kilo ohm, and there's a capacitor with 5 nanofarad. So here the question is, we need to determine the power factor, active power, reactive power and the apparent power. So we need to find those four values. If you already knew the equation, please pause the video and try to do it in your own. After that, watch the rest of the video and check your answer with mine. Okay, let's start with the first one. The first one, they are asking the power factor. Actually, we knew that, but the power factor, when we are considering about the power factor, it's going to be the cos phi. The phi simply states that's the phase angle between the real voltage, the total voltage of that source, and the current. So we need to find what's the angle between these two. Actually, you can, for that you need to draw the phasor diagram for this circuit. After that only you can figure it out what's the value of phi. When you are considering about these two, actually we knew that as these two are in the series, we can directly take, we are going to take the I as reference, because actually we have already discussed that when they are having the series circuit, we can directly take that I reference, because the I is, the current is going to be the same for these two elements because they are in the series. So first of all, when we are considering about the voltage with reference to this, say I for this resistor, we knew that when we are comparing about the resistor is going to have the phase difference of 0 with the I and the voltage across that resistor. So you can draw it like this, that when you are drawing this I, it's going to have the phasor angle between the VR and the I would be 0. After that, I'm going to continue with the capacitor. When we are considering about the capacitor, actually we knew that the capacitor's voltage is going to lag the current. We knew that the current is in the horizontal direction, and it's going to be the same for the capacitor too because of the series. And after that, we are going to check that whether the voltage of the capacitor is going to be in, whether it's going to be in the upside direction or downside direction. Actually, it's going to be in the downside direction because the voltage across the capacitor is going to lag the current in the capacitor. Actually, we knew the capacitor's current is in this way, so the voltage would be in this side. This is the voltage of capacitors. Actually, we can figure it out these values. However, I'm not going to do that now. So that the resultant would be in this direction. The resultant voltage would be in the reverse direction. Actually, we knew that when we are considering about the phase angle, we need to take the voltage in the engineering usage. Actually, we normally take the voltage as the reference. So from the voltage line, the resultant voltage, what's the phi angle is making to that I, the current, for that resultant current in that circuit. So we are going to take as a voltage as a reference when we are considering about the power factors phi, the phase angle. Actually, you can take the I also, but normally in the engineering usage, we normally take from the voltage side. Okay, so these are the values. So we need to find this phi. Actually, we can find the phi using the trigonometric values. If you find the tan phi, it's going to return the value of the tan phi would be equals to VC over VR. So the question is, we need to find the VC to figure it out, the tan phi. After that, we can convert it to cos phi. Actually, we need the value of cos phi. So for that, we need to know the value of VR. We can directly find the VR. They have already given. They have already given the total current, we can find the current, and it's going to be the resistor part. So we can directly write it's going to be the I. It's going to be the same for this part too. Actually, we can write it like this. It's going to be I into XC. Likewise, using the Ohm's law, you can directly write it like IR. And actually, we knew that these I are same over here, so we can directly tell it's going to return the value of XC over R. So R value we have already given, so you can directly use this 1 kilo ohm for this part. And the next part is, actually we knew the capacitance. So how we are going to find this capacitance value over here? So that's the question. How we find that? It's going to be 1 over omega C. Actually, we have already studied that. When you are considering about the inductor, it's going to be inductor, the reactance of inductor, it's going to be omega into L. Likewise, when you are considering about the capacitance reactance, is going to be 1 over omega C. So I am going to directly write that. So it's going to be 1 over omega C divided by R. So here actually we knew the value of capacitance, which is 5 nanofarad, and the resistor, which is 1 kilo ohm. So how we are going to find the value of omega? So let's check at the data they have provided. So we have used these two data, and 15 voltage we haven't used it yet, but they have given the frequency of that circuit voltage. So we can directly use this circuit's frequency to find the omega of that capacitor. It's going to be omega is equals to 2 pi f. From that, if you substitute the frequency value over here, 10, which is 10 kilohertz, from that you can find the value of omega. So from that you can easily figure it out the value. The XC would be, this reactance of that capacitance would be 3183 ohms. Actually, we need the value of R, which is 1 kilo ohm, which is, I'm going to write it like 1000 ohms, so that we can directly tell the tan phi is going to be 3183 over 1000, which is 3.183. From that you can figure it out the value of theta using the calculator. If you don't know how to use the engineering calculator, I have given the link in the description, so you can always watch that. Okay, the angle would be 72.56. But be careful when you are considering about that. Sometimes if you use the negative sign over here for the VC, you are going to get the answer in the minus. However, when you are considering about this part as the reference, the voltage as a reference, when you are considering about the power factor, normally we assume at the reference as the voltage. So when we are considering about the power factor, actually the question is about the power factor, so we need to find the power factor over here. So power factor is going to be cos phi. So you can directly write it as cos 72.56, which is giving the answer of 0.2997. And it's going to leading, because when you are considering about the voltage as a reference, the I is going to be leading. So when you are considering about the power factor, normally we will use the voltage as a reference, so I is going to lead that. So you can put that also. So the next part is, we need to find the active power. So the next part we are going to move to find the active power. If you know the equation, please try it in your own, so it would be more useful for you guys. So let's write it as active power. Actually, the equation of that active power would be VI into power factor VI cos phi. So we need to figure out the value of voltage, the resultant voltage, and the resultant I, and this cos phi. So how we are going to find that? Actually, we knew the value of cos phi, and after that we can find the value of voltage, because when we are considering about these two voltages, the resultant voltage would be equivalent to this 15 voltage, because we are going to give that 15 voltage to that circuit, but in that circuit there are only two elements in the series. So these two elements resultant voltage across these two elements, which is this part, is going to be 15. So you can directly use that. So the voltage would be 15. However, actually we don't know the value of I, and we knew the value of power factor. So how are we going to find the value of I? So that's the next thrilling part. How we can find that? Have you got any ideas? Actually, when we are considering about that, we know the voltage difference between these two values, which is 15 voltage. If you know the resistant part and the reactant part of this, which is simply known as impedance, which is, we know the impedance of these two elements across these points, it's 2 points, we can directly use the Ohm's law and find the current between that. Otherwise, we can find the voltage across this element only and use the V is equals to IR equation. From that, we can find the answer. There are a lot of ways, but here it would be easy because the first method would be easy because the voltage difference between these 2 points we actually already calculated. So now we are going to find the total impedance, and after that we are going to use the Ohm's law, which is equals to V is equals to I into XC impedance. From that we are going to find the value of I. So the main part is we are going to find the XC over here, impedance part. XC. Sorry, that's not XC, it's going to be X, the total impedance. So let's write it like Z. So when we are considering about this, the resistance part would be, when we are considering about this two impedances, which is one is resistant and which is only having the reactance, there are two impedances. This is one impedance and this is another impedance. When we are considering about the two impedances which are in the series, we can directly add these two. So that's the concept. We have already learned about that. If you don't know, please refer our previous video. Z1 plus Z2. So the next part is, actually we knew the value of Z1, which is 1 kilo ohm. So we can directly write it like 1000 plus J0. If you want to introduce the complex number part, you can directly write it like the reactant part of that impedance would be 0. Likewise, you can directly write for Z2, it's going to be, actually we figure it out the value of 1 over omega C, which XC, which is 3183. So I'm going to use that. So the real part is going to be 0, resistant part of the capacitor is going to be 0, and the reactance part would be 3183J. And be careful, it's going to be minus, because it's going to be in the negative direction. So from that you can directly write it like this: 1000 plus, sorry, this is going to be minus 3183J. Now we have figured out the Z value and we knew the value of voltage. So the next part is we need to figure it out the I, the current value. You can do it in many ways. However, we can use, actually you can say change this part to the polar form. After that you can directly divide it by the voltage. However, here I'm going to use something different. You can easily figure it out using the calculator. You can directly use this value and divided by this voltage, and divided by this value from that voltage, and directly figure out the value of I. So I'm going to use that method. So V is equal to I into Z. Actually you can change it manually and try that method. However, I'm going to use the calculator, you can directly use that with this complex Cartesian form. So when we are considering about the V into IZ, the Z would be equals to V over I. So let's use the calculator over here. So I'm going to change this part, the calculator part, to complex number first. So let's move to complex number. The next part is I'm going to change whether I'm going to check whether the output is in the polar form, so it would be easy to find the magnitude of that complex number. So I'm going to change it for complex number in polar form. So the output is going to be in that polar form. So the thing is, first of all, we need to write the voltage value. It's going to be 15, and actually we can give the phase angle. However, if you don't have, or actually it's 0, because in this case they haven't mentioned that, so we are going to take the reference as voltage. So it's going to be 0, so I'm not going to use that 0. If you like, you can put it that value too. So I'm going to divide this part by the Z, which is 1000 minus 3183J. 3183 into I'm going to press this. Yes, it's correct. If you wish, you can multiply. Okay. So if I click the enter, let's see what would be the answer, whether it's giving the answer. Okay, it has given the answer 0.0044. So remember, this is going to be the I. So I need to write it like the I is equal to V over Z. It's okay. So the I is going to be 0.0044. This is the magnitude of that, which is the RMS value of that I. So it's going to be IM ampere, and the phase angle, it has already repeated like this, 72.55. Actually we have already figured it out in this case, so there's no wrong. So the next part is how we are going to use this. When you are considering about this, the voltage would be this part, which we have already found, 15 voltage. That we need to use the RMS value of for this equation. The I would be 0.00449. We can directly write it like 4.49 milliampere, which is 10 to the power minus 3. And the cos phi, we need to figure it out, the value of cos phi, which is 0.2997. From that, you can directly solve that. It's going to be 20.21 into 10 to the power minus 3. So if you write it like this, milli, and it's going to be, the unit would be watt, milliwatt. Likewise, when we are considering about the apparent power, you need to figure it out the value of V into I. It's going to return the apparent power would be 67.44 milli, be careful of the units, volt ampere. So I'm going to leave the last question with you. You need to figure it out the value of reactive power. Actually, you knew the equation, which is VI sine 5, so you need to figure it out the value and be careful of that unit. Please remember that and try to do that in your own and leave that in the comment section, so I can also check your answer and your peers also check the answer with yours. Thank you for watching. If you have any doubts, please comment it below and please consider subscribing Expert Tutor. Thank you.